Welcome to your deep dive. Today, we're going to crack open this LLM engineering manual that you sent us. Get ready, you'll be going from, total LLM newbie to, well, informed insider.
Took a backstage pass to the whole world of LLMs, really.
So much goes into these systems.
Yeah.
So first things first, what actually are LLMs? I hear people throwing around like GPT-4 and all that, but it all kind of sounds like science fiction to me.
Okay, well, think of it like this. Imagine, your phone's autocomplete, but, on steroids. You know what I mean?
Okay.
So that's the basic idea behind an LLM. They're trained on just mountains and mountains of text data.
Wow.
And this allows them to, generate human-quality writing, answer tricky questions, even translate languages instantly.
Okay, that makes sense. But then what makes LLMs so different from, say, the chat bots I encounter on websites? Those are usually, super frustrating.
Well, the LLM engineering manual actually dives into the history of this.
Yeah.
And it's really, really fascinating. We've come a long way from the basic rule-based systems, right?
Yeah. The real turning point was when they introduced this revolutionary new architecture called transformers.
Oh, transformers. Now that rings a bell. Is this where we get into those attention mechanisms I've heard about?
Exactly. So before transformers, AI was processing language bit by bit, word by word.
Okay.
But with these attention mechanisms, suddenly these models could analyze entire sentences all at once.
Huh.
Really grasping the nuances of context and relationships between words. It's like the difference between reading one word at a time versus absorbing an entire paragraph, in a single glance.
Well, it's not just understanding the individual words, but getting the bigger picture of what's being said.
Exactly. And this was a total game changer. I mean, think about something like GPT-4 translating a complex legal document from English to Mandarin.
Wow.
The attention mechanism lets it maintain those legal nuances and context, something older systems just couldn't handle. That's wild.
Yeah.
So beyond chat bots and translation, what other practical applications do LLMs have? I'm guessing our learner listeners super eager to hear about how this impacts their world directly.
Well, let's take education, for example. The manual talks about how LLMs can be used to create personalized learning experiences, really tailored to each student's needs.
So no more generic feedback. Students could get specific guidance.
Yeah. Imagine AI tools that can assess a student's writing style and suggest specific areas for improvement all in real time.
That's a game changer for education.
Definitely. And for researchers, LLMs are becoming invaluable assistants. Imagine automating that super tedious process of reviewing mountains of scientific literature.
Oh, yeah.
LLMs can sift through those research papers,
Wow.
extract key findings, even identify potential gaps in, existing knowledge.
I would save so much time.
Oh, yeah. Countless hours. Potentially leading to new discoveries, too.
I'm starting to see how this technology can impact pretty much every field. But I'm also kind of getting the sense that building these LLMs is a monumental task. It can't just be a few clever lines of code, right?
You're absolutely right. Creating these powerful LLMs requires, serious hardware, not just software.
Right.
We're talking GPUs and TPUs. These specialized processing units designed for the really heavy lifting that these models demand, and the memory needed to handle the massive data sets and all those billions of parameters in the model. It's mind-boggling.
It's you're building a supercomputer just to run these things.
In a way, yeah. And then there's the software side, right?
Right.
Tools like TensorFlow and PyTorch, those provide the frameworks for building these complex deep learning models.
Yeah.
But even with those tools, training an LLM from scratch, it's like baking a cake from individual grains of wheat.
Right.
It's so time-consuming and resource-intensive.
Wow, okay. So how do engineers even make this process manageable? I've heard people whisper about pre-trained models.
Right.
What's the deal with those?
Pre-trained models are the secret weapon of LLM engineering. Think of them as the cake mix in our baking analogy.
Okay.
So someone else has done all that heavy lifting of training a model on this huge data set, and you just get to leverage all that work.
So you don't have to start from scratch.
Exactly. Instead of starting from scratch, and engineers can just take these pre-trained models and kind of adapt them for specific tasks.
That sounds like a huge time saver.
It is. And these pre-trained models are available through, platforms like Hugging Face Transformers. It's become kind of a hub for the AI community, really, offering a library of, ready-to-go models and tools that make the whole process much more accessible.
So it's like having this like giant toolbox of pre-built AI components.
That's a great way to put it. And this is where things get really exciting. By fine-tuning these pre-trained models, you can adapt them for, really specific tasks. So for example, you can take a general language model and fine-tune it to be like a whiz at analyzing financial documents or medical records.
This is mind-blowing.
Mhm.
But it makes me wonder, with all this power, at their fingertips, what are some of the key challenges that LLM engineers even face? I'm guessing it's not all like smooth sailing.
You're right. One of the biggest hurdles is dealing with the sheer scale of these models.
Yeah.
Billions of parameters. It requires massive amounts of data, and that data needs to be like carefully cleaned and prepped before training. The manual actually gets into the nitty-gritty of this data pipeline. It's a lot more complex than just throwing like any old text at the model.
So there's a whole art to preparing the data to make sure that the LLM actually learns effectively.
Absolutely. It's like preparing a gourmet meal for a picky eater. You need the right ingredients, the right proportions, and the right presentation. And then there's the challenge of actually training these models. We're talking about, distributing the workload across clusters of these super powerful computers,
Right.
right? And making sure they all work together seamlessly.
So it's a massive coordination effort, not just a single person, like writing code on their laptop.
Not at all. It's a whole team effort,
Yeah.
involving data scientists, software engineers, even hardware design experts. And then there's this constant push for optimization,
Yeah. Yeah.
making the training process faster, more efficient, and less energy intensive.
So it sounds like building an LLM is kind of like launching a space mission, a very complex dance of cutting edge technology and human ingenuity.
That's a great analogy. And we haven't even touched on the real world applications of these models yet. That's where things get really interesting. And that's what we'll explore in part 2 of this deep dive.
Okay, I'm on the edge of my seat. Can't wait to hear what you have in store for us next time.
Stay tuned. We'll be back with more mind-blowing insights into the world of LLMs.
Welcome back. Last time we kind of laid the groundwork for understanding, what LLMs are and how they're built. Now I'm ready to hear about the truly cutting edge stuff, the future of LLM engineering.
Yeah.
What's the LLM engineering manual say about what's on the horizon?
Well, one area that's really pushing the boundaries is something called few-shot learning.
Few-shot learning. Okay, I'm intrigued, but I'm also a bit confused. How can a model learn from just a handful of examples? It seems like it'd need mountains of data to, grasp a new concept.
Right, that was the conventional wisdom for a long time, but researchers have actually found ways to train LLMs to be incredibly adaptable. So imagine you want to train an LLM to translate a specific type of legal document, say from English to Japanese.
Right.
In the past, you'd need thousands of examples of these documents, meticulously translated. But with few-shot learning, you might only need a few dozen examples, or even less.
So the LLM is somehow able to extrapolate from a very small data set and apply that knowledge to completely new situations.
Exactly. The manual actually highlights a study where they used GPT-3 for few-shot learning in translation tasks. And the results were remarkable. It opens up a whole new world of possibilities for adapting LLMs to new domains and challenges much faster and way more efficiently.
Like teaching a child a new concept, you don't need to drill them with endless repetitions. They can often grasp the idea from a few well-chosen examples.
That's a great analogy. And this adaptability is a key feature of, human intelligence. So it kind of makes sense that we're seeing it emerge in these advanced AI systems.
That's really cool. So what other areas of research are pushing the boundaries of what LLMs can do? I'm ready for more mind-blowing insights.
All right, well, and another fascinating area is the development of multimodal models.
Multimodal models.
So remember how we talked about LLMs being trained on massive amounts of text data?
Yeah.
Well, multimodal models are designed to process not just text, but also images, audio, even video, all at the same time.
So instead of just understanding words, these models can analyze an image, listen to a piece of music, and connect all those different inputs to form a more holistic understanding.
Precisely. Think about a model that can analyze a medical image, like an X-ray, and then generate a detailed report
Okay.
that incorporates both the visual data and relevant information from the patient's medical records.
Wow. That's incredible. It's like having a doctor with superhuman perception,
Oh.
able to see patterns and connections that might be missed by the human eye.
Yeah. And these multimodal models aren't just limited to Healthcare. Imagine an LLM that can, you know, analyze a product design sketch,
Okay.
understand the designer's intent, and then suggest improvements based on things like manufacturing constraints, material properties, even like aesthetic trends.
It sounds like we're moving towards LLMs that can truly understand the world in a much richer and more nuanced way, similar to, how humans do.
That's the exciting part. We're seeing LLMs evolve beyond like purely language-based systems, right? To
Mm.
become more integrated with like the diverse ways that we experience and interact with the world.
This is all incredibly promising, but I can't help but think back to our conversation about the challenges of, building and deploying these LLMs. Are those challenges like amplified with these advanced capabilities?
Of course, with greater power comes greater responsibility,
Right,
right?
right.
And the need for like careful engineering becomes even more critical. One of the ongoing challenges with LLMs, especially as they become, more complex, is
Mhm.
this issue of interpretability.
Interpretability. What do you mean by that?
So it's the ability to understand how an LLM actually arrives at its decisions. These models are often referred to as like black boxes,
Mhm.
right? Because we can't always easily trace the reasoning behind their outputs. We might see a correct answer or like a beautifully written piece of text, but we might not fully understand why the LLM made those specific choices.
So even if the output seems like accurate or unbiased, we might not know what data or like internal logics led to that result.
Exactly. And this lack of transparency can make it difficult to like fully trust these systems, especially when they're being used in, critical applications like
Hmm.
healthcare or finance.
It seems like a fundamental challenge. Like, how do you build trust in a system whose decision-making process is, essentially opaque?
That's why research into like LLM interpretability is so important. We need
Yeah.
like tools and techniques that allow us to kind of peer inside these black boxes and understand how they're working. It's like
Wow.
having a mechanic who can not only, fix your car, but also explain exactly what they did and why.
That makes a lot of sense. And
Yep.
I imagine this challenge becomes even more complex with these multimodal models that are like processing all these different types of data.
Absolutely. Imagine a multimodal LLM that's used to like screen job applicants.
Yeah. Okay. Yeah.
It might analyze resumes, video interviews, even like social media profiles.
Wow.
How do you ensure that such a system isn't like making biased decisions based on, factors like gender, race, or socioeconomic background?
It's a sobering reminder that even with the best intentions, these technologies can like perpetuate existing societal biases if we're not incredibly careful.
That's why it's so crucial to have like interdisciplinary teams working on these systems, bringing together, experts in AI, ethics, social sciences, even law. We need these diverse perspectives to ensure that these, powerful tools are developed and deployed responsibly.
So it sounds like the future of LLM engineering isn't just about like pushing the boundaries of what's technically possible, but also about having these like critical conversations about how to ensure these systems, benefit humanity as a whole.
That's exactly right. And that brings us to some of the broader trends that might shape the future of LLMs trends that go beyond just the technology itself. Are you ready to explore those?
Absolutely. Let's dive in. Welcome back to the final part of our LLM deep dive. So far, we've gone from like the basics of what LLMs are to these like mind-blowing possibilities of few-shot learning and multimodal AI. It's like taking a crash course in the future.
It is pretty remarkable how quickly this field is advancing.
It really is.
But like we've been talking about, it's not just about the raw, technological power.
That-
It's about how we harness that power,
Yeah.
responsibly, ethically.
That's a point the LLM engineering manual really drives home.
Yeah.
It's not just about building these impressive systems, but like making sure those systems serve humanity in, a positive way.
Exactly. I mean, think about how LLMs are already being integrated into our daily lives, from like the recommendations we get on streaming services to the chatbots we interact with on websites.
Right.
As these systems get more sophisticated, more pervasive, the impact they have on society is only going to grow.
So it's not just about the code itself, but about the values that are kind of embedded in that code,
Right.
the biases that might be lurking in the data, and the potential consequences of, deploying these systems without careful consideration.
Precisely. It's like building a bridge, right?
Yeah.
You need to think not just about like the structural integrity, but also about like the traffic flow, the impact on the surrounding environment, the safety of the people who will be using it.
That's a great analogy. And it highlights the need for like a broader conversation about the role of LLMs in society. It's not just a technical issue, it's a social issue, even like a philosophical issue.
Absolutely. We need to ask ourselves, like, what kind of world do we want to create with these LLMs?
Yeah.
How can we ensure that these systems are used to, empower individuals,
Hmm.
to foster creativity and understanding, to solve, like, these pressing problems?
Those are big questions. And I don't think there are any like easy answers. It feels like we're at like a pivotal moment in the development of this technology,
Yeah.
a moment where we need to carefully consider the path we want to take.
I agree. The future of LLMs isn't, predetermined. It's something that we're actively shaping, With every line of code we write, every data set we curate, every decision we make about how these systems are deployed.
So it's a call to action,
Yeah.
not just for like engineers and researchers, but for all of us to engage in this conversation,
Yeah.
to think critically about the implications of this technology and like demand that it's used for good.
That's a great way to put it. The future of LLMs isn't something that's like happening to us. It's something we're all creating together.
We've given our learner-listener a lot to ponder. As we wrap up this deep dive into the world of LLMs, we hope you come away with a sense of, both the incredible potential and the profound responsibility that comes with this technology. Keep learning, keep exploring, and keep asking those, tough questions.
And who knows, maybe you'll be the one building the next groundbreaking LLM application or like shaping the ethical guidelines that ensure these systems benefit humanity for generations to come.
On that note, we'll catch you on the next deep dive. Thanks for joining us.